Welcome back. This is Professor Xiao Ma. So far, you have learned to train several classification algorithms. When we evaluate the model performance, we have been using the accuracy. Model accuracy measures the percent of correct classification out of the entire training set or test set. Model accuracy is not the only metric to evaluate model performance. And in fact, in many cases, model accuracy is not even an appropriate measure. This measure could mislead your judgment about how well the model is doing. When it comes to business decision making, and particularly in the healthcare domain, there are many other evaluation metrics. Some of them are more appropriate than accuracy. This week's special module will focus on several of those new concepts and tools, including the ROC curve, which you might have heard about. To motivate you a little bit, I will talk about a few fundamental concepts. For a binary classification, you know that there are two target labels. So far, I have referred to those target labels by using a specific meaning, for instance, default or non-default. In this week, I will introduce an alternative way to refer to the labels, positive outcome and negative outcome. A positive outcome refers to the target label that is of primary interest to the project or the researcher, the most important to be identified or classified. Negative outcome refers to the other outcome, the outcome that is not of primary interest. It's important to emphasize that the word positive or negative does not carry a meaning of good or bad. It simply differentiates the primary versus the secondary outcome of a problem. So to make it clear, I will use red to indicate positive outcome and green to indicate negative outcome throughout this video. And to use a business case as an example, in the credit card account default problem, the primary outcome of interest is the account default. So the other outcome, when the account didn't default and the account remains healthy, is the negative outcome. When the classification algorithm makes a classification, it might be a correct or an incorrect hit. By using the concepts introduced just now, positive or negative outcome, there may be four scenarios. When the classification is a correct hit, it might be that a positive outcome is correctly classified as a positive outcome, or it could also be that a negative outcome is correctly classified as a negative case. Whereas when the classification is an incorrect hit, it could be that a positive outcome is incorrectly classified as negative, or a negative outcome is incorrectly classified as positive. Therefore, you have four possibilities when it comes to a classification result. And in the next slides, I will talk about these four concepts. True positive refers to this case, positive classified as positive. False negative refers to this case, positive classified as negative. True negative refers to this case, negative classified as negative. And false positive refers to this case, negative classified as positive. These four outcomes can be put in a table which is referred to as confusion matrix. In the next slide, I'll explain the details. The confusion matrix may be confusing at first, but it's critical to recognize how to properly arrange the table so that it will become comfortable to your eyes. Over and over, when you review the table using the same consistent format, you will become much more familiar. When you arrange the confusion matrix, it's often the best practice to arrange the actual outcomes, the actual target labels, as the rows of the table. Their labels are denoted on the left side, and you arrange the prediction or the classification results as columns, so their labels are on the top. To begin reading this table, you find that the two cells on the diagonal line denote the correct hits, and the two cells off diagonal refer to the incorrect hits. Hence, the correct hits have the true as a leading letter, and the incorrect hits have the false as a leading letter. And next, you'll observe that when the classification is a correct hit, the labels are not confusing. When the correct hit is about a positive case, it's a true positive. And when the correct hit is about a negative case, it's true negative. It's when the hit is incorrect, the labels become confusing. But you can stick to a routine here. When it comes to false predictions, the label follows the prediction label as a column header, not the row header. So when a positive case is incorrectly classified as negative, it's a false negative. Observe that the second letter corresponds to the header of the column. Whereas when a negative outcome is incorrectly classified as positive, it's called false positive. In the case of loan applications, which error, false positive versus false negative, which error is more consequential? Meaning, if you would make a choice between these two errors, which one leads to loss of more money or which one leads to earning less money? In this case, it would be false positive, because when the algorithm makes a false positive classification, it leads to incorrect approval of the loan application of low-income earners, which leads to a higher likelihood of loan default. Whereas if the algorithm commits a false negative error, it will reject a loan application because algorithm determined that this person is low income, is negative outcome, where in fact the person is higher income earner. The company lost a business. However, losing one loan application and the resulting potential income from that one application is far less than the default amount of the loan if the loan is default because of low income. So false positive error is more consequential than false negative error per error based. Now let's look at this example, which is more severe or more consequential in the decision making of sending direct mail solicitations for donation. Let's take a look at the decisions here. The primary outcome of one would be to classify or to detect that somebody is a donor, and the negative outcome would be to determine that somebody is a non-donor. So when you commit a false positive error, the algorithm mistakenly determined that this person is likely a donor, whereas in fact this person is a non-donor. So under the classification of a donor, the company will send a solicitation to solicit donation, but in fact, the company will not get donation because the person actually is a non-donor. In contrast, in the case of false negative, the algorithm determines that the person will be likely a non-donor, and company will follow the recommendation to not send a mail. But since it's a false negative, the person actually would be a donor if he or she received a mail, but unfortunately the company did not send a mail, so the person would for sure not donate due to no solicitation. So in this case, in the direct mail solicitation case, which error is more severe, more consequential? Now in this case, you would have to calculate the cost and benefit. In the case of false positive, algorithm determined that the person would likely be a donor, will send a mail which costs perhaps less than $1. But the company will not get anything in return. The benefit will likely be $0. So that is in the case of false positive. But in the case of false negative, because algorithm determined that the person will be a non-donor, the cost will be zero because by following the classification result, the company will not send a mail. By not sending a mail, there will be no benefit. There will be no benefit here. However, there is potential benefit of a large donation here. It could be to the magnitude of $100 or something dollars. In the case of false negative, making this kind of mistake will lose the company a potential donation of $100 by not sending a mail. So in this case, the error of false negative is more consequential. It leads to lost potential revenue for the company. I hope this makes sense. And now let's look at the third example here. The case is what's more severe in the decision making of detecting cancer, which is similar to a fire alarm. In medical diagnosis, there is a false positive kind of alarm versus a false negative. Which one is more consequential? I'll let you think about it. I'll talk about it in a few seconds. Now, in the case of a medical diagnosis or fire alarm. In fact, false negative would be more severe. And here's why. The primary case here would be referring to fire or disease. And so in this case, the primary outcome is not a desirable outcome. When the algorithm commits a false positive error, it is a false alarm. It alarms the patient the possibility of the disease and calls for action. So the cost here would be inconvenience in the case of fire, because everybody has to leave the building for firefighters to diagnose the building. And in the case of medical disease, it is alarming the patient to do a follow-up check. The cost may be in tens or up to a couple hundred for the diagnosis, but the potential benefit is to rule out the disease, because if the case is a false positive, then the follow-up test or the firefighter's check-in will rule out the case that this is actually a fire or disease, so there's no fire. The false positive will be corrected by a second chance. However, in the case of false negative, the algorithm determined that there is nothing to be alarmed. It's a negative classification, whereas in fact there might be, or there's in fact a fire or a disease. In this case, people continue being in the building and have a far higher likelihood of death due to the fire being out of control, or a false negative in the medical case will lead to a loss of opportunity for the patient to catch the disease in early stage, and it would be too late for the patient to seek for medical help when the disease, especially cancer, in late stage. So in this case, false negative leads to missed opportunity of diagnosing the cancer, which leads to cancer being in late stage and higher likelihood of death, because death is more costly than other inconveniences and cost of a couple $100. So in this case, false negative error would be more severe. If you compare the second with the third scenario, the determination that the false negative error is more severe or more consequential is regardless of whether or not the primary outcome is a desirable or non-desirable outcome. In the second scenario, primary outcome is a donor and it's a desirable outcome, whereas in the third scenario, fire or disease is a non-desirable outcome. However, the determination that the false negative error is more consequential is the same here. I hope this exercise is interesting. Okay, confusion matrix will be the foundational concept, which includes the 4 classification results. We will refer to these as we go through the module this week. That's it for the preparation video. I'll see you in the class.